All right, now that we've created our project and looked at some of the include files and its dependencies, we want to start by creating new files to put our code in. We're going to create a file for each one of the hardware elements we're interacting with, a driver file. If you're coming from a Java background, you might make one file. Let's say we're going to do the LED. We'll do the LED first, and so you'd create an LED file for your Java code, and in there you'd have your class definitions, and you'd also have all the implementations in one file, and you'd import that file anywhere you wanted to use it. Well, C doesn't quite work that way. In C, there's a distinction between the definition of the file and the declaration, as it's called in C. So putting out the actual prototype of what the interface is to the file, the function calls, things of that nature, is distinct from the actual implementation itself. So let's walk through that. We'll use the LED file first to do this. First thing we're going to do is create, add a couple items. We're going to create an led.c file, and then we're going to create an led.h file. Using our templates here. Okay, let's start by looking at the led.h. In your led.h file, we're going to declare the things that are public interface. It could be, again, come in Java, like your methods. Well, this is your public interface to the system. So one of the things we'll have in just about every one of these driver files is a void and a init function. So in this case, the void means that there's no return expected. LED init's the name of the function, and there are no parameters to it. So that's how we're declaring this function. We're going to have some function we want where we can set the file, or set the LED. And in here, I want to do which LED I want to set, and some value I want to set it to. However, I need types on these. Okay, the compiler needs to know how big is this parameter. So let's take a moment to talk about types in C. In C, there are 4 types: char, int, float, and double. Those are the 4 main types in C. Char is just a single byte data type. It's used obviously for characters. A string, if you use a string, there's no string type in C. A string is just a collection of an array of chars with a null termination on it in C, but it's not an official C type. So there's the char type. Ints are integer types. Float is the IEEE 32-bit floating point representation, and double is the IEEE 64-bit floating point representation. So we can do these, but we will not use them much because floating point isn't something that's inherent in our hardware. There's floating point libraries that C will use to do that, so we can use floats, but it's going to build a whole library with it, so it's not our standard data type. We'll get rid of those just to look at. So we've got chars and ints. Again, char is defined to be 8 bits, but an int in C is not defined. The size type is not defined. It could be 1 byte, 2 bytes, 4 bytes, whatever the architecture wanted it to be. C has qualifiers on ints. You can have let's start with just signed and unsigned. Forgot to mention those. Without the unsigned on it, it's obvious it's signed. You could say signed, but it's not necessary. So signed int and int are the same thing. But if I want an unsigned int, which is pretty common for us to deal with in most of our embedded code, I can have size qualifiers on it. So I can have a short unsigned int. Well, how does that compare to an int? Well, we said an int, we don't know how big it is. It's the same for a short int. A short int could be any size as well, but it has to be the same size or smaller than an int. You can also have a long int. It has to be the same size or bigger than an int. You can also have a long int, which, if you're following me now, has to be the same size or bigger than a long int. Well, this is very unfortunate in an embedded world where we want to know how big our types are that we're dealing with. What I really want to know is, I know char is 1 byte. how do I get a 2-byte value or a 4-byte int? What do I want to do when I want one of those? So C has a feature created called a typedef, where you can typedef some type, like an unsigned int, to some name like my type. And now I can type my type, and it becomes a type. You see how the IDE picked it up right there. So I can have my type A, as opposed to unsigned, or unsinged, but unsigned int A. Those would say the exact same thing because my type's then been typed as an unsigned int. Okay? So let's get rid of all that for a minute. Go back to our problem. What I'd really like to have in here when I type this, I want this to be an unsigned integer, but I only need 1 byte to hold it. So how can I do that? Well, I can use this nomenclature, uint8 underscore t led. And the same thing here, uint8 underscore t value. Those are declared as unsigned ints, 8 bits. Now, where does that come from? That actually comes from a file called stdint. It's been included automatically in here, but if it wasn't, I would do this, stdint.h. So stdint.h is the file that defines these data types. Let's take a moment and go look at that file. To do this, we're going to look for the AVR GCC library, AVR libc homepage. It's Savannah, that's the one we want. I can come over here and look at the online users manual and go to the library reference. This is a pretty handy thing to have around. This is a list of all kinds of libraries and functions we'll be using as we go further with C. Standard string.h library, where you do string compares, string copies, your standard C library you see in most systems. Standard io.h we'll play with later. It has printf. We'll learn how to use that later. But the one we want right now is standard int, which I can't find. There it is. Stdint.h. And here you can see what it does at the very beginning. This is the function in it. It typedefs a signed character int 8 underscore p and an unsigned character uint 8 underscore p. On this particular implementation of this machine, the AVR, the ints are 16 bits, so 2 bytes. So a normal signed int is an int 16, and unsigned int is a uint 16. The longs are 32 bits, and the longs are 64 bits. And again, this isn't the same on every machine. If you look on your laptop, your ints are probably 4 bytes. But in this machine, the ints are 2, long ints are 4, the longs are 8. So this gives us the ability to just use a standard integer type, uint8, that specifies how big the type actually is. So if I go look at my file here, what I'll find in my dependencies is that stdint.h. And when I look at the stdint.h, here's the actual typedefs that were mentioned. Okay, so that's where those are coming from. We will use those types heavily in all of our code. And I'll take this out since I don't need it because it's already in there from the IDE. So I've declared this. So this function LED set, I want to be a function that will take in the LED RGB 0 or 1 and give it some value. In order to do that, I need to kind of create, well, I don't have to do this. I always pass a number there. It would be nice if I gave some words or constants to pass those numbers in. So I'll paste this in here. I'm using these as a RGB value, the lower 3 bits RGB, which means if they're all zeros, it's black. They're all, if it's 001, it's blue. Right? So zeros, the red and green are off, blue. Right? If it's a 2, the green's on. If the green and blue are both on, I have cyan. So that's our colors. So now I can use that. I can pass that value in. So any file that includes this led.h can now call these function calls, led.init or led.set, and has access to these constants, led black, green, cyan, red. It will be our custom to always precede any defines or function calls with the name of the module. So this is led.c and h, the led module. We'll put everything led underscore function call or led underscore whatever we're defining. All right. I'm going to add one more thing in here for later. I want to have a led set. I'm calling it led set value. But in this case, I want to be able to set both LEDs at once with one single byte value. And we'll look at the implementation of that later. That's going to be useful for the rotary function where I just want to hit both LEDs in one shot with a 1 byte value. Okay, so let's save that, and that'll be our .h file. We'll come back in a minute and look at the .c file.